Then we move for question number 2. Is going to be question number 2. So for the following figure, there is a coefficient of kinetic friction. This question there are not a lot of spaces. So I'll just read this. So for the following figure, there is a coefficient of friction. Let's say mu as the coefficient of friction 0.20 between the blocks and the ink. Find the following. We have also given points for this question. So it's the constant force F required to keep the blocks moving up the incline with a constant velocity, assuming they were already moving, and B is the constant force between the two blocks. So I will just draw this diagram. We have the degree, we have a box, we have a this is 3 kilo, this one is 2 kilograms force, this F this direction, and obviously the block will move in direction. So here we are just going to resolve these vectors. So let's say this whole system a mass of, let's say, capital N. So capital N will be kilos. So it is the combined mass of these two blocks. Then there will be weight acting in downward direction. This will be E. Then we can take the components of force. This will be equal to E. This will be normal. So this angle is going to be 30 degree because this one is 30. Then we have this triangle, and when we complete this triangle, we use some basic trigonometric or mathematical geometrical identities. Just find out, and this angle will be 30 degree. Then this will be cos 30 degree, and this component will be 30 degree. Now we can see that. So let's just draw the force diagram. So this was capital N, this was normal force, which is E cos 30. This is the force in direction, E 30 force which is in the opposite direction of this parallel. Then if the block is moving in downward direction, then there will be friction in the opposite direction. Friction force will be this direction, in the direction of capital F. And friction force, normal force, coefficient of friction. So we'll just write the equation. So my F plus All F equal to V sine 30 degree will be 3 degree. All F is cosine 30 degree times. Now I can say that take the common. So this M is going to be the capital M, mass of whole combined sine 3 minus 0.2 times 30. So we can always use a calculator for this. This will be 3 minus 0.2 into cosine 3 0.3267. So this will become the total mass is 5 kilos. 5 into acceleration due to gravity to 0.326. So I'll do the multiplication here. We have 16.01295 and this was 4, so this will be Newton. So let's just check the curve. They have given 32.98. I'm not sure. I'll just cross check this. They had just 0.22. This was cosine t. Okay, was minus. I did mistake. This will be this be this was minus 0.2 into cosine of 30. This will be 0.32. Then multiplied by 5 and then 9 point. Hope I was correct previously. 0125. Okay, now I see. So they have basically added the full friction force. They thought that let me just read the question between the constant force F required to keep the assumed they were already moving. Force F required to keep the blocks moving up the incline, the constant velocity. They will move the incline to keep the blocks moving up the incline with a constant velocity. Okay, so this is a pretty much force required to keep the block moving line. Okay, So basically, this question, uh, this question is pretty much, it is a different kind of question because these blocks are upward direction due to this force. If they are moving in upward direction, then friction will always be in the, so friction is this, therefore will be minus, will be minus, or then it will, and hence will be 0.673 multiplied by 9, and now it will be 32 point. So this here you can also see, and I can also see, that each and every word in the problem of physics problem is very much important, because each and every word can change the problem. So initially I was assuming that we need to find the force to keep this block at zero velocity or at stationary, but later on I found out that the blocks are moving in upward direction, and we need to find the force to keep this block moving in upward direction, and that will be with constant velocity. So this was the A part. Now we'll go for B part, the constant force between two blocks. So the force between two blocks, the same as the force need to keep the block 3 kg moving up the incline with constant velocity. So the force between two blocks will be the same as the force need to keep block 3 kg moving up incline with constant velocity. So in this case, for B part, we need to find the force, this 3 kg block. So we just need to find the F, this 3 kg block, and we are going to use the same equation. So in this equation, instead of putting capital MS5, we will put capital MSE. So it will be 3. This sign and these terms will be same. F will be same. So sin T and cosine 30 will be same. So till here it will be same. So 5 will be putting 3. This will be given from 319.7922 newtons. 15.79 newtons. So the solution given here is correct. Good work.